Hi, I'm Henry and I'll be doing 7.4. Alright, the question in 7.4 is, or A, is use bond enthalpies to estimate the enthalpy change for the reaction of hydrogen with ethene. Wait, no, ethylene. Okay, so in this case, hydrogen, since it's in its base form, is H2, and then ethylene, C2H4, is going to be double-bounded carbon, each with two hydrogens on the edge. So they're going to look like this, that being the H2 gas and that being ethylene. Alright? So then let's find the bond energies of each. Hydrogen and hydrogen is 436. Double carbon bond is 614. And I'm going to hold off on calculating the carbon hydrogens for a second, and I'll show you why. So let's see that hydrogen and ethylene combine to form C2H6 or ethane, right? So that goes to C2H6. And C2H6 is single bonded carbon, each with three hydrogens, which looks like that. That being C2H6 over there. Alright? So now, if you notice, so we're going to be taking the reactants and subtracting the product, yeah? So we can actually cancel out some of the bonds. So 4 of the hydrogen bonds in ethane are also in ethylene, so we can ignore them on both sides. So I just struck a line through all the bonds that are redundant, okay? And so now we effectively only have 2 carbon-hydrogen bonds on this end, if that makes any sense. So now carbon-hydrogen is 413, so then we have 826 for the 2 hydrogens, carbon-hydrogen bonds that are left. And then carbon-carbon is, let me see, that's 348. And then on that end we have 436 and 614. And I believe that is everything, so then just do a little arithmetic, and that's 1050 minus minus 1174. Yay. And then, so that ends up being 124. So then the net change in enthalpy is negative 124. But, so that was how we calculated the enthalpy using individual bonds, yeah? But you can also calculate enthalpy by just using this wonderful textbook, looking in the appendix. Alright, so let's find these enthalpies for each of the compounds in the appendix. Alright, we have that here on page A21. First, I guess we should do... First, we know that H2 hydrogen is going to be 0, because... We know that H2 hydrogen is going to be 0 because of the fact that it's its base form, so that's 0. And then So you go to carbene, carbon. We have C2H4 is 52. It's HF. And then C2H6. So it's positive 52, which we're going to flip to a negative. And then C2H6 is negative 84.7. So then just do some arithmetic there. You have negative 86, and then you have negative 136.7. So that's negative 136.7 as opposed to negative 124. And the reason they're different is because when you calculate by the individual bonds, that's actually just taking the average delta H for that bond, like throughout all molecules or whatever. And so that can be a little bit different based on like things like electronegativity and like other bonds in the atom, things like that. So it is a little bit different than the average, but it's a good general method if you can't find it in the appendix, or if you don't have the appendix to use, you can use individual bond energies. And that is 0.74.